Hello there, welcome to this lesson. This lesson is based on question 5, that is the continuation of our exam preparation series. And in this question, we interact with a quadratic sequence. Okay, so what is the question? Take a look. Okay, so quadratic sequences have a second constant difference. And looking at the board, I have indicated the first 4 stops or the first 4 terms for us here, and we need to perform some investigation here to find out what is that second constant difference. Okay, so this is your first difference row. What is happening there? We have 18. What is happening there? That is 14. And there, what is happening? That is 10. So our second difference is what? Negative 4. Okay, and the first question that is asked is to write down the number of passengers that will be on the 5th stop. Okay, so should we continue this investigation, we'll definitely have a 6 there, and that will give you a 50. Okay, and it continues to have a second constant difference there. So definitely the answer for A is 50 passengers. Okay, we're given the quadratic equation or the general formula in variables A, B, and C are not determined yet. Question B is asking us now to determine the values of those 3 variables. Okay, so what do we need? We need the value of A, B, and C, and we understand the following. That always work with the first branch, okay, and link your 3 equations. This is a 2a, 3a plus b, a plus b plus c. Link your 3 equations correctly from the bottom to the top. Okay, you always work upwards in a quadratic sequence. So we have 2a is equal to negative 4, and therefore a is equal to negative 2. 3 times negative 2 plus b is equal to 18. Okay, what is this? Negative 6 plus b equal to 18. You transpose, you get 24. Okay, a, negative 2 plus 24 plus c, okay, is equal to 2. This gives you 22. You minus, you get a negative 20. Okay, so therefore, the general formula Tn is negative 2n squared plus 24n minus 20. This takes care of question A and B under question 5. Let us go to question C. All right, so question C is asking us if Tn is equal to negative 2n squared plus 24n minus 20, determine the maximum number of passengers on the bus. Does it make sense for the examiner to ask you to get the maximum? Yes. Remember that this equation is a quadratic equation. Under functions, it represents what type of function? A parabola. Concavity, concave down in this case, because the coefficient of n squared is a negative number, and therefore it does have at some point a maximum there called the turning point. Okay, so that makes sense. So there are 2 methods that I will present here in order to get a solution to this question, getting the maximum number of passengers. Okay, so you can find the derivative and solve for n, substitute that n value back into the original equation to solve for the corresponding value which will represent your maximum. So how? We find the first derivative, Tn prime, okay, of the expression. So it's negative 4n plus 24, okay? So at the maximum, what is happening? We know that derivative will be equal to 0. Okay, so we have negative 4n plus 24 equal to 0. And if you then transpose, you'll see that n is equal to 6. Okay, therefore, to get the maximum, we substitute the 6 back into the original formula. So Tn actually becomes T6, which is equal to negative 2, 6 squared plus 24 times 6 minus 20. If you perform this calculation, you'll get 52 passengers. Okay, maximum of 52 passengers on the bus. This side, we can work with completing the square because we're going to take the standard format of a quadratic equation into a turning point format, which represents the turning point of the parabola. Okay, so what do we have? We have a coefficient of negative 2. First step of completing the square is to ensure that the coefficient of the leading term is 1. So it's not, we need to factorize. So Tn is equal to negative 2. What is happening? N squared minus 12n plus 10. Correct? So completing the square will happen within the brackets. So we have a negative 2, n squared minus 12n. We add and subtract half of the square of the coefficient of the middle term. Okay, so half of 12 is 6. So actually you can take the sign, but it doesn't matter because the square of negative numbers is positive. So that's fine. Plus 10. Okay, so there we are. This square now is complete. All the 3 terms are there. So if negative 2, what is happening now? N minus 6 all square. And here we're going to have a negative 36 plus 10, giving you a negative 26. Right? We are not done. We need to redistribute the negative 2, giving you a negative 2, and minus 6 squared plus 52. Okay, the beauty of mathematics. Do you see the turning point now? Turning point will be 652. Totally in agreement with what we've done here. Okay, so definitely there'll be 52 passengers as the maximum number of passengers on this bus. This takes care of question C, and let's look forward now to the last question, question D, under question 5. Take a look. Now we are asked to explain why the formula in question 5C does not work after the 11th stop. Remember that the whole context is really a relationship between the number of stops and the number of passengers, both of which must be positive values. Okay, doesn't make practical sense for them to be negative. So then our stance that we take is to talk about an inequality and take this into an inequality and say it must always be greater or equal to 0. Find critical values and test where it will be positive or equal to 0, right? So this expression right here must be greater or equal to 0. Okay, how do we proceed? Factorization or just using quadratic formula? Your critical values here is 6 plus or minus square root of 26. If you go to the number line and represent it there, that is 11.09, and the other one is 0.9. This tells us that this is where the graph cuts the x-axis, and this is the turning point. Remember, this is 52, okay? Meaning that after the 11th stop, function will have negative y values. Okay, so if I go to t12 here and I substitute 12 here, I will definitely get a negative value because look at this. You see, that is what is happening there graphically. Okay, you can test it for yourself and you'll see that you get a negative 20 for t12. So this is going to work only for when the graph is above the n-axis. This is the tn axis, and between 0.9 and 11.09. And this is the sufficient explanation that we can offer as to why this formula here doesn't work when we have passed the 11th stop. Okay, hope this makes sense. You can rewind and obviously watch the video again if you really need to clarify some points, but this will take care of question 5, and we are now moving on to question 6. See you on the other side. Sharp, sharp.